So with 18 and 19 on page 506, what is this, 7.5? 7.6, 7.5? We're dealing with similar shapes. And in this case, they happen to be polygons. And when they're similar, that means they're proportional. Okay? Now, we were talking about this yesterday, and dealing with perimeter is pretty easy. Dealing with area is a little different. Okay? And so, I want to go into why area is different and how we're going to deal with it. So, this bigger one has a side. Just one of the sides is 90 meters, right? And then this polygon is similar to it, and its side is 60, I believe. That is similar to that side, right? So 60 meters, okay? And it says that this parameter is 381. Okay? This area is 1944. And when you're doing perimeter, you're just adding up the sides, right? And so since you're just adding up the sides, everything is proportional to each other. Okay? And so like we showed yesterday, I could really easily set this up as 90 is to 60, right? As 381 is to unknown. I don't know, right? This P, I have no idea, so we'll call it X. Okay? And, or we could call it P. It doesn't really matter. And then we do the cross multiplying, right? Like we did yesterday. And it's intense. It's a little intense. It's not that hard, though. Remember, when we do this, keep your numbers separate. You don't have to multiply the numbers like you did in the old days, right? Realize your rules of mathematics, and they're powerful rules. They let us deal with things. So I have 90x is equal to 60 times 381, right? And then I'm going to divide by 90. And I'm going to divide this by 90. So I get x is equal to 60 times 381 divided by 90, right? And so then we did that upside down division that, I've been showing you for 2 years now, and hopefully for some of you, this is your first year in the class, right? So you're like, I don't like this stuff. Believe me, this upside down division works. I know people fight me on it because it's funky, right? But it works. Now, as long as we I usually start with primes, right? But when we're breaking down a fraction, we don't have to start with primes. When we're dealing with radicals, we want to deal with primes because we're pulling out pairs, or we're pulling out triples, or we're pulling out, quads. It just depends on the radical, okay? But when we're pulling out, breaking down a fraction, we just want to get it as small, as quickly as possible. And I notice that a 10 goes into these two numbers. And remember, if I multiply this out, it's one number, right? And I'd only take the 10 out of one of those numbers, that one number, right? Even after I multiply this out. So by it being separated, I'm still only going to take it out of one of these numbers that's multiplied. Now if it's adding, we got to take it out of everybody on the block, right? But when it's multiplying, we don't. We just take it out of one. So 10 goes into 60 6 times, right? And so we get 6 times 381. And 10 goes into 90 9 times, right? And so then we're going to go, okay, what goes into 6 and 9? 3, okay? So we just keep playing with those numbers until we break them down as far as we can, right? So 3 goes into 6 twice, and 3 goes into 9 3 times, right? And then we're like, well, I can't break down the 2 into 3 anymore, right? But does 3 go into 381? And we use that trick. 3 plus 8 plus 1. So that's That's, what is that, 11 plus 1 is 12, right? So does 3 go into 12? Yes, so 3 goes into 381. And so we do that. And we say, okay, 3 goes into 3, so the 2 comes down, right? But 3 goes into 3 once, 3 goes into 8 twice, right? With 2 left over. And so 3 goes into 21 7 times. And so now I've got 127. It's that simple. Short division. You're using that short division. Short division is, I'm dividing it into this. There's nothing left over. Dividing it into this. There's 2 left over. The 2 is with the 1. It's 21. Is that making sense? Right? Short division. We keep working this. Practice is short division. Believe me. Now, can you use a calculator on the EOC? Yes. Can you use a calculator now? Yes. But practice this. Believe me, it works. Okay? Then I just multiply this out. 2 times 2, or 2 times 100 is 200, right? And then 2 times 20 is 40. And 2 times 7 is 14, right? And I just think of it that way. Instead of trying to just do it all, I just think of it in 3 different pieces. And so now I've got, that's 54, so that's 254. Okay? So it should be 254, and it is. Yeah. Okay, there's an easier way to get there. Believe it or not. Right? There's an easier way. And the way is this. We know that this is proportional, right? Right? So that means that something, right? Something, let's say, instead of x, because that's what we've used over here, let's just say the ratio, r, right? The ratio, right, times 90 is going to equal 60. Some ratio that I do to multiply 90 is going to equal 60. Does that make sense? Okay? Because it's proportional. Okay? So I divide by 90. Okay? So I get r is equal to 60 over 90. And again, upside down division. 10. So I get 6 over 9. 3. Looking familiar? So goes in there twice and 3 times, right? So the r, our ratio, is 2/3. And if we take that 2/3 and multiply it by p, right? We'll just so happen to get 254. Right? Because think about it. What's p? 381. 381. What's our r? 2/3. That's exactly what we did. It just took us a lot longer to get there. Okay? So this is a little quicker way of dealing with it. Okay? Find the ratio. Once you have the ratio, you can find any side. Real easy. Does that make sense? Proportions mean there's a ratio. Ratio means something multiplies that to give you that. Okay? Now, here's the problem. When we go to area isn't just adding up all the sides, is it? It's multiplying 2 different things, right? It's saying, hey, we make this triangle, and we say this height times this base, right, times 1/2. Then we make this triangle and do the same thing. Then we do this triangle and do the same thing. And then this triangle and do the same thing. And the next thing you know, you add up all those triangles and you know the area of the polygon, right? And that's a lot of work. We don't have to do that here because we know they're similar. But we do know that they're multiplying, right? They're squared. This answer is in meters. This answer is in meters squared. So what we're going to have to do with this r is we're going to have to find a, right? We're going to have to take r squared. Right? And r squared multiplied against a is going to give us y. That's it. That's all it is to it. And so I take this r, so 2/3 and I square it times the A, and it equals y, right? But the A in this case is 1944. Okay? And what is r squared? Well, it's 2 times 2 and 3 times 3. Alright, so 2 times 2 is 4, and 3 times 3 is 9. Times 1944. Now, we still have to do that upside down division, right? And the 4 and the 9 don't break down. So, we got to figure out, does 3 go into this? Right? That's what I would want to work with first. Before I work with a 9, right? Because, I mean, 9 might go into it. You know, we can try it, right? 9 goes into 19?
It's
18. 18, right? With 1 left over then, right? So twice with 1 left over. So we're saying the 4 comes down, then we got twice with